Hi guys, and welcome to Lecture 4 video. Today I'll be talking about abstractions. Before we do that, let's do some review. So we learned that our server could talk to a database via something called SQL commands. We talked about relationships like one-to-one, one-to-many, and many-to-many, and how you can relate different types of data with something called a foreign key. So here's our one-to-one example where you have one user to one profile and vice versa. And this is our one-to-many example where you have lots of songs for an album, but you don't have lots of albums for a song. So that's why it's one-to-many. This is our many-to-many relationship where you could have many students enrolled in a course, and you can also have a student taking multiple courses. So that's why you have many-to-many. And we have a join table so that we don't duplicate our information. So students are abstracted away from courses, and likewise courses are abstracted away from students. And you have one table that will connect them together. And this is just some lovely animations showing you how that works. All right, let's talk about some drawbacks with SQL. So if you noticed, PA1, we made it better by not using a Python dictionary, and we're gonna do a better optimization here. So let's talk about what SQL is not good for. It's not very readable. As you can probably guess, if you have a lot of columns, you're just going to be saying select column 1, column 2, column 3, column 4, column 5 from your table where, I don't know, you have some elaborate condition. It's also susceptible to vulnerabilities, and I'll go more in depth with that with an example later. And if you noticed, if something was wrong in your SQL code, you couldn't really catch the exception there. You had to catch it the entire SQL command and then try and guess what went wrong. So you can't really give helpful descriptive error messages back to your clients. This is an example of something that I have no idea what the heck is, and that just shows you that, you could have readable things, but because you have so many columns and so much data that you want, it's just not scalable. Some vulnerabilities, you actually might have heard this, is that let's say you're a hacker and you're browsing someone's website, you could actually inject some code into whatever form input they give you and essentially extract passwords, change data, and stuff like that. So here's an example. Let's try to break this login page on someone's website where people are expected to enter their emails and passwords, but what you could do is, knowing that people are going to be injecting their SQL code to extract or to actually enter in a new user, you can inject your SQL code as part of the variable that they put in, if that makes sense. So here you could just say, give me all the users who have this password in this email. And here's some other examples. And you can be very elaborate with this and keep on going. And honestly, the list goes on. So we're going to offer another solution, which is Object Relational Mapping, also known as ORM. So here we're going to treat our objects as abstractions, meaning we're going to treat rows and our columns as objects, and we're going to abstract that away from directly manipulating our database. So we're not really going to be using SQL commands. This lets us reason about the stuff in our database at a higher level, and we leave all of this, sticky SQL commands to a package or a library that we use, so we don't have to deal with all of these security hazards. So here's an example of what this would look like. So here's SQL code, very raw. Let's say someone was trying to fill out a form, they could probably inject SQL code at name or age. But here in an ORM, we've completely abstracted away from that, and we're just creating a class. And whatever package we use, they're going to deal with actually converting this to SQL code. What we're going to be using this course is SQLAlchemy. So in our starter code and in our, assignment code too, and the requirements.txt, it should have SQLAlchemy there. So remember to upgrade your virtual environment so that you have this package. This is a really popular ORM for Python, and it comes with a lot of query patterns that you can use. It can help you define relationships and all that, and it integrates really well with Flask. So note the difference between Flask and SQLAlchemy. Flask is a web framework that lets us define routes and map routes to code, and SQLAlchemy lets us define our database and the schema for that and how clients can basically work with that. And together, it creates a backend. So some benefits of ORM. Well, it's readable, unlike just using raw SQL code. It's abstract, so you don't have to worry about the specific syntax. I'm sure you guys got pretty annoyed with the semicolons and the commas. And also, if you noticed, a lot of, there's a lot of different ways that you can implement your database actually. So you don't even have to use SQL. You don't even have to use SQLAlchemy. So that's the beauty of using an ORM. If you abstract your code away and you just at a high level define what the classes are and which columns you want for the fields, you can use anything you want. You can use NoSQL, MongoDB. You can use a different database actually entirely. So it's really great if you don't want to commit to a single type of database. And it's also secure against injections and vulnerabilities. All right, so there's a lot of benefits to ORM, but there's also some drawbacks. But honestly, I actually think the benefits outweigh the drawbacks a lot, and you guys will come to see that when you work on your assignment. But basically, it's a lot slower. So you can think of it as, from C++ and C to Python, there's a big performance difference because you have to interpret your C and C++ code into Python. So it's kind of like this, right? So you have SQLite code or SQL code that's really, low level and you work directly with a database, but here you have something that converts that. So it will take some time. It can abstract away too much from SQL, so I don't know if you want to really learn SQL and be a database engineer, you won't be really getting that much here because you're just going to be abstracted away from that encode, but I don't really think that's a con. And it could potentially be too abstract and you could forget about optimizing things. So, these are all quote-unquote drawbacks, but they're very tiny in the grand scheme of things. So if you want to build a scalable backend, I think ORM is the way to go. And all right, that concludes our Lecture 4 video.